We're moving into factoring by grouping. Your first two sets of notes for this unit, the first one went over those special products, factoring special products like difference of squares, difference in sum of cubes. And then the second set of notes, you need both these papers over here, the purple and the white. The second set of notes went over factoring your degree 3 and 4 polynomials. So when the exponent, the highest exponent is a 3 or a 4. Okay, so now we're going to review our factoring by grouping. Okay, so always, same as yesterday, same as the last set of notes, when you're looking to factor whatever it is, both of those pages, it is always, the first step is to look for a GCF, a greatest common factor. Okay, so our greatest common factor in this first one would be what? What can I divide out of both 50 and 72? Both are even numbers, aren't they? Okay, so at least a 2. And then if you think maybe it's higher, you can look higher. Now that purple sheet I gave you today with your notes is a list of factors. Okay, so you could go and look at 50 and 72's list and see what do they have in common. So on the list for 50, you should see 1 and 50, 2 and 25, 5 and 10. So then on the list for 72, the only one that I see there that is the same is the 2. Does everybody agree? And that's what you're using this factor list for. Okay, it'll help you look for those common factors if you struggle with knowing factors of numbers. So 2 is the only thing that I can divide out of both. Now the lead term, we always want to factor out, it says up here, if the lead coefficient is negative, factor it out. Okay, we always take out the negative. So our leading coefficient is negative 50. So we're definitely going to take out the negative, and then we said 2. We can't take out a variable r because the second term doesn't have an r. So negative 2 is it. So you put your GCF, and then in parentheses, the quotient, what's left once you do that division. So here, negative 50 divided by negative 2 would be 25. And then the r squared. Positive 72 divided by negative 2. So the positive divided by the negative means we're going to have a negative, so a minus, and that's 36. Okay, once you've factored out your GCF, remember we check if we're left with a binomial, okay, 2 terms, bi means 2. We want to double check, is it any of those special ones that we talked about? Is it a difference of squares, a sum or difference of cubes? So this one's definitely a difference. I see a minus sign. Okay, are both of these, we can see clearly it's a square on the variable, not a cube. So is this a difference of perfect squares? Are 25 and 36 both perfect squares? And you can look on the first reference sheet I gave you with the last set of notes, and it has a list of all the perfect squares, and you should see 25 and 36 are both on there. So this is a difference of squares that we talked about on the last set of notes. So difference of 2 squares, or dots is how I abbreviate that. So that means I can factor that binomial into 2 binomials. Okay, where I take the square root of each of these terms, okay, and separate, put the square root of each into these binomials. So the square root of 25r squared would be 5r. The square root of 36 would be 6. You just sit there, thank you. And then remember, one gets a plus, one gets a minus. Okay, so that's factoring difference of 2 squares. The GCF that was out front, that negative 2, did not go anywhere. It's still there. Now, when I look at how I have factored within each of these, there's nothing further I can do, okay? They're linear factors now, Okay, there's no exponent on any of those variables, so I know I can't take it any further. So that's it. Okay, if you need to reference what I did in pink, the difference of two squares, you need to look on one of the last two sets of notes that we did in this unit. Because that formula, okay, for difference of two squares is on both of those. It's on the reference sheet and the last two sets of notes. All right, here we've got 4 terms. Okay, is there a GCF amongst all 4 of these? There's not, is there? So no GCF to take out. So this says when the polynomial has 4 terms, we're going to do factor by grouping. Okay, so factor by grouping means we create groups. So I'm going to color code some parentheses here. So I'm going to group the first 2 together with orange, and then we'll do green for the second 2. So we create our 2 groups. Now within each group, you're going to do the GCF. Okay, so this is the first group. What is the GCF of this first set of parentheses? What can be divided out of both x cubed and x squared? X squared. If I divide both of these by x squared, let's list what is going to be left. So here that would be an x. And here, anything divided by itself is 1. You have to write the 1. It doesn't just disappear. It's not 0. Okay, now in the second group, I'm going to do the same thing. Okay, I'm going to do GCF of the green group. Okay, if nothing can be factored out, it's just a 1. You still have to write what is factored out. And here it would just be a positive 1. Okay, and there's nothing left that besides that you can factor out. So you're just left with x minus 1. Now, when you're doing your grouping, remember, we want the leftovers, okay, what's left here in the parentheses of both of these to be the same, okay? That's a hint or a clue that you've done the right thing here. So we know that x minus 1 is a factor, and then you bring together your GCFs. So that x squared and then the plus 1 come together here. Now, I'm going to take a look at this. These are both binomials and see, can I take this any further? So this one in yellow is linear, so definitely can't go further there. This one is squared. 1 is a perfect square, x squared is a perfect square, but that's a plus sign. Okay, we can only factor difference of 2 squares, not sum of 2 squares. Okay, so I can't do anything further with this, so I am done. Okay, if you want to make a note that we checked to see if we could take it further, make a note that we checked that. All right, here's a more complex one. This one does have a GCF, but is it going to be GCFs of groups, or is there something I can take out of all 4 of these before I start? This last one doesn't have B, so they don't all have the variable. It starts to look like a 3, but 4 can't be divided by 3. So there's not a GCF at the beginning, but once I make my 2 groups, there's GCFs that can be divided out. So with the first group, the 12b cubed minus 9b squared, what GCF can be taken out? What can you divide out of both of those? The 3, and what about for the variable? B squared, good. So 3b squared comes out, and that's going to leave me 12 divided by 3 is 4. B cubed divided by b squared is b. Negative 9 divided by 3 is negative 3. And b squared divided by b squared reduces to just a 1. So that's still just a 3. Okay, so then in my second group, both of those pages, I look again, is there something that can be factored out of both of those? And again, in this one, there can't. Okay, it's just that understood 1. So a plus 1 again, which leaves me with 4b minus 3. But that's okay because now my leftovers match, don't they? So I know 4b minus 3 is a factor. And then I bring together my GCFs that I pulled out, which was 3b squared plus 1. Again, I can't do anything further with that. 3 is not a perfect square or cube, so that's it. That's as far as I can take it. All right, now you've got options with 4 terms here. We could go ahead and do our grouping, and then one of our factors is going to have a GCF again that we take out, or we can just take out that GCF now at the beginning. I always like to just take out the GCF at the beginning. So what can be divided out of all of these? Definitely the n. They all have an n, but look at the numbers again. 5. They all end in 5 or 0, so you know they're all divisible by 5. Okay, and again, that purple sheet that I gave you this morning that has all the factors on it, you can look and see what are all of these numbers divided by 5. Okay, you have a quick reference sheet here that you can look at. Okay, so if I take 5n out of everything, that is going to leave me, let's see, that would be 14, or excuse me, 15 in cubed. Okay, and then 45 divided by 5 would be 9. So it's going to be minus 9 in squared. And then this one will be positive 10n. And then this will be minus 6. Okay, and the n's reduced. So the n's gone completely from that term. Now I've still got 4 terms, so within that, I'm going to do my grouping. So I'm going to group the first 2 and the last 2. So I'm just going to focus on these in the color right now, in the orange first. So what can I divide out of both 15n cubed and negative 9n squared? Definitely n squared. And then 15 and 9 are both divisible by 3. So 3n squared. So that would leave me with 5n. And then that would be minus 3. And then in green, what could I divide both 6 and 10n by? Just a 2. So a positive 2. So I'm going to put the plus 2. And that would leave me with 5n minus 3. I forgot to show the division up here. That was, oh, I drew the line. I just didn't put 3n squared. There we go. All right. So again, this is all inside here. We've still got that 5n in front, right? Didn't go away. Oops, that was supposed to be an eraser. Okay. So now my leftovers for what I was doing grouping in here are again the same. So that's a good sign. So I know I've got 5n minus 3. And then I bring together 3n squared plus 2. Nothing that I can take further. And then I've still got that 5n in front. So this one has 3 factors. Okay, and none of them can be taken any further than that. So that's as far as I can go. Okay, so some of these have lots of steps, there's lots of terms. So just take your time and make sure that your work is shown clearly and you're just being careful. Okay, so now in this last couple on the back, they both start with a negative. The leading coefficient is negative. So we definitely know we want to divide out at least a negative. And then let's look and see, is there any factor that they have in common? Let's see, yeah, 3. Yep, those can all be divided by 3. And what about the variables? Do they all have the same variables? X squared is going to be what we can take out of all of them, right? So we're going to do negative 3x squared. And then I'm going to put in parentheses what's left when I do that division. So negative 45 divided by negative 3 will be 15. It's going to be positive now because we did a negative divided by negative. And x to the 5th divided by x squared will leave me with x cubed. Okay, so this sign is going to change to negative 20x squared. This sign will change to negative 6x. And this sign will change to positive, and that will be 8. And the x is reduced completely. Y'all agree? So now we'll create our groups. Oops, that's supposed to be orange. First group, what's the GCF here? 15x cubed minus 20x squared. Definitely both divisible by 5, and then x squared. That would leave me with 3x minus 4. Okay, the second group. Both are divisible by 2. The lead term is negative, so I want to factor out that negative 2. So that's going to be a negative 2 outside. It's going to leave me with positive 3x, and then 8 divided by negative 2 will be minus 4. Okay, so that's from doing the grouping. Then I've still got that negative 3x squared out front. So what is left over in here is the same. So that's a factor. Okay, and then we're going to bring together those GCFs from grouping. That will be 5x squared minus 2. And then we've got our original GCF of negative 3x squared. So now I take a double look at these. I do have a difference in x squared. Some of y'all immediately want to do difference of squared because you see a minus and a squared, but 5 and 2 are not perfect squares, are they? So we can't do that. Okay, there's nothing further we can do with any of those. We are done factoring. All right, last but not least. Okay, I'm going to go a little bit quicker. Okay, we're getting the hang of this. Okay, so I'm looking for a GCF, definitely the negative, because I don't want the lead term to be negative. So I'm going to divide out a negative. 20, 16, 30, and 24. Definitely 2, because they're all even. See if I can go more. 4 will go into 20 and 16. 4 won't go into 30, so I can't do 4. Let's see, 5 won't go into 16. I think it's just going to be the 2. But then the variable is t cubed. So negative 2t cubed. So what's going to be left will be positive 10t cubed That will become, all these signs are going to change because we divided by a negative. Minus 8t squared minus 15t plus 12. And then I'll do my grouping. So those are divisible by 2t squared. Would leave me with 5t minus 4. Definitely take out the negative, and they're both divisible by 3. That would be 5t minus 4. Looks good because my leftovers are the same. So 5t minus 4 is definitely a factor. Then I bring those GCFs from in there together. Again, I see a minus and a square, but 2 and 3 are not perfect squares. And then I don't forget the original GCF that I took out. It's still out there. All right. You'll feel like you kind of got the hang of grouping, factoring by grouping. It is a lot of writing that looks messy and confusing, so I tried to color code it for you. You're welcome to borrow colored pencils or highlighters if you want to highlight your different steps or use the colored pencils. But that's the process. Okay. If you do your grouping first, if you didn't do the GCF to start with, you're going to get your 2 groups, and one of them is going to have a GCF that you can then still pull out. So these will work out if you start with the grouping process and then do the additional GCF at the end, if you prefer it that way. For some people, it's easier to see GCFs in like just the binomials rather than across all 4 terms. And so that's okay if that's how you want to do it. Just take your time, work carefully. Okay, show that work, show your steps. So if you're getting something wrong, I can look and see where you're making your mistake. You can use the whiteboards back here for scratch work, or you can get some paper, just paper and pencil. That's fine too. Okay, I'm going to activate your practice in Delta Math. Okay, if you want to finish a past assignment first before starting today's, you're welcome to do that.